Hi everyone and welcome to another episode of Matter for Thought. The guest for today is Wade's Underworld. Wade, you can take it.
Hi there. As promised, in this episode we will deal with motion at a constant rate on one axis and with constant acceleration on another axis. The most common case of such motion is motion due to the acceleration of gravity, or as it is called in the physics language, ballistic motion. Ballistic motion is the motion of a body that receives a certain initial velocity, magnitude, and direction, and from a certain movement on. The only thing that affects the motion is the acceleration of gravity. The acceleration of gravity was first measured by Galileo in a series of groundbreaking experiments and is nearly 10 meters per second squared towards the ground. Before we move to the more complex cases, I want to talk about the simple case where the initial velocity vector v0 has no magnitude, that is, 0 in all axes. In this case, the object begins at rest at some height, r0, and accumulates velocity downwards until it hits the ground or anything else between it and the ground. This motion, quite naturally, was given the name freefall. In the case where the initial velocity is greater than 0, the situation is a little more complex, but not too much. The velocity in a horizontal axis is maintained, but the velocity in a vertical axis varies according to the acceleration of gravity. In physics courses, the example is a cannon that fires a shell, and I do not think there is any point in changing it. Suppose the cannon and the target are on the same plane, and the cannon is aimed at an angle of 37 degrees, that is, a ratio of 3 to 4. Just so that there are comfortable numbers to work with. So, how far will the shell go if the speed it receives at the moment of firing is 500 meters per second? This was not a rhetorical question. Let's do the math. The formula for location vector under acceleration is r at t equals r0 plus v0t plus 0.5 at squared. Let's replace what we know in two axes, height and distance. 0, 0, plus 400, 300, t plus 0 minus 4.9, t squared equals question. We actually have two equations. The first one in the horizontal axis, which is without acceleration, 400t equals what? Which is literally the formula of velocity multiplied by time equals distance. We only need to know the time. And the second one, in the vertical axis, that includes both velocity and acceleration, minus 4.9 t squared plus 300t equals 0. That is, we need to calculate how long it will take for the acceleration of gravity to make the right part be 0, and the time we got, we'll put it in the first equation. We take t out as a common factor and get t minus 4.9 t plus 300 equals 0. That is, the elevation 0 of the shell is once at a time 0. That is, the moment of firing. Now we find what the second time is, which is the impact. Divide by t and get 4.9t equals 300. Divide by 4.9 and we get that t equals 61.2. So the shell hits the ground at time 61.2 seconds from the firing. Now we need to put that value in the second equation to get the distance. And this is what we get. 400 times 61.2 equals 24,480 meters. In the next episode, we will be introduced to the full form of the quadratic equation, which is a cornerstone in physics in general and motion under acceleration in particular. And we will also see how to solve it, so that we can solve slightly more complicated problems related to ballistic motion.
Thanks a lot. And that's for today, friends. If there is something not clear enough, feel free to contact me. My contact info is in the description. Before I wrap things up, I want to thank my patrons. If you find the content good, a link to my Patreon is in the description. Feel free to like and share, subscribe to the channel, and please leave a comment. I was, as always, rndthinker, and see you in the next video.